Hi, my name's Irrelevant, and recently my Atomos AC adapter stopped working. And that's just not gonna do. So as the story goes, I went to, start a broadcast day, and I turned on my Atomos, or at least I tried to, and it wouldn't turn on. And I thought to myself, uh-oh, what now? Old used unit? Has it failed already? But no, it's just the AC adapter. And sure enough, if we test it on the meter, yeah, there are no volts coming out of it. So let's investigate. Now this thing isn't actually a normal AC adapter, it's like a battery adapter. Now I'm not sure if I'd trust putting this battery on other things that take the Sony type battery, but I don't know, it might be based on a standard. But I'm hoping I can maybe take this apart and determine maybe what's going wrong with it. Now this thing right here is very lightweight and flimsy and hollow, and I doubt there's anything going wrong in here. A loose wire? Unlikely. So I feel the culprit might be more in this guy. Now it's got this slide-on adapter here. That's how they make it universal for different countries. And I don't like, the margin of error for this particular piece is going to be extremely low, so I'm not too worried about it. Now, the question is, can we find some screw holes or something on here? Pressing on the sticker here, I can't find any divots. This might be a good old-fashioned situation where we're just going to have to crack this thing open and see what's inside. Now, I'm under the impression that this thing's fried, so that's not going to be a whole huge hell of a loss. Ultimately, at the end of the day, it's a question of getting this cable off and getting 9 volts onto it. Because yes, even though this is a battery adapter, and those are lithium-ion batteries rated from 7.2 to 8.4 volts, this thing's rated for 9 volts. Oh, it was UL listed. How sad. It'd be nice if it screwed together, but these things rarely do. So let's see if we can probe on in here. Oh yeah, nothing's coming loose there. Well, sometimes what you do is you drag across here. Seems soft enough plastic, I'll get through it in no time, but this could take a little bit of work. The crappy thing is, if I do find a repairable fault inside this unit, getting it back together is going to be tricky. Yeah, combinations of tapes and glues and whatnot. Yeah, what happens if we get a little bit more persuasive with something with pry capabilities? Oh. It's starting to feel promising on that side. This plastic shears off real easy. What happens if I apply a little bit of persuasion? Oh, there's a possibility I might have stabbed some electronics there. Let's get in the other side a bit. Crackety crack. Release the kraken. Hey, there we go. And it looks relatively healthy inside here, actually. Yeah, I didn't damage anything. It's kind of stuck in here, though. Oh boy. This business here, and what connects to here, is glued. So that's not going to pop out. I'm going to have to bust out the heat iron and manually loosen it. All right, then. Heat iron it is. On the bright side, this spring mechanism looks like it's going to stay into place. I see a fuse. Let's see here. Now, those line and neutral connections might come unsoldered, but it might still have some glue sticking the PCB in there a little bit, so... Okay, I think I got the line disconnected. Or no, I don't know that I did yet. That time for sure. Taking some creativity with my fingers. There. Okay. And there was a kind of little ferrule that was in there. But those are kind of out now. There's those things. And still got the ferrule on this side. And yeah, there was like a little bit of glue kind of stuff. Just kind of stuck to the board, making it a little bit harder to get that off there. There's some sort of date code on here, 9160. I guess that's not a date code. It wouldn't make sense. Or wait, 0916. That makes more sense. 2009. Okay, we've located a timed 1 amp fuse. Just turn on the meter and test on this fuse. Yeah, it's never the fuse. It's literally never the fuse. These things, they blow up all the time, but it's never the fuse. There's a diode here that looks a little sketchy. No, test's fine. Oh yes, unfortunately I don't see anything obviously wrong with this. Couple little micro circuits there. Could be one of those is fried. I do not have the pay grade to test those. So we'll do some other just continuity tests, sanity checks. So, you know, connect line to line here. Yeah, that tests out. Investigate this line here. Yeah, that checks out. Now how about in the main wire itself? So we'll hook onto this negative here and get the actual PCB and find, oh, is that the connection side? Look at that, no signal. How about the other one? Okay, we got a positive signal here, but how about this negative signal? Oh, do we just have a bad wire, sir? Maybe this power supply is perfectly fine. Maybe we should charge it up and test on it, which was hard to do before inside the enclosure, but we might be able to set up a rather sterile laboratory test now. Grabbing a random lead from the scraps of buckets, but it's not quite a bucket, it's more of a bin. I'm gonna install this wire on there. All right, now we have the ability to get power back to this thing. We just need to reorganize the workbench a little bit so that we don't have any electrical mistakes happen. That might entail clamping this down safely somehow. All right, clamp safely. In the jaws of the rubber, you know, there's nylon soft jaws. It shouldn't be causing any short circuits. So maybe if very carefully, sir, we go over here and plug it in and hope for no explosions. Good, no explosions. This should be live now. Keep your fingers out of there. Now let's switch this pupper back to voltage mode and let's test on this. Oh, look at that. We got power output from the power supply itself. Well, this solves half of our problems. It means for some reason there's a failure in this cable. Let's unplug this thing and let it cool down. So what is the story here then? Did I accidentally pinch this cable? Let's search the cable to find fault. This is a flimsy little cable. No, I don't see any damage to it, and it's unlikely that anything went wrong with the cable itself. Ugh, that means we have to open up this guy right here, and this guy is not something that wants to be opened. I can tell you that right now. And we know it's a fault on the negative terminal. So, I guess YOLO, right? Aha! Look at that! Look at that right there. And let me guess, that's the negative, right? That's the negative. Now, how is that even possible? This wire is sealed in there. It cannot be jostled. How does it just come off like that? That is crazy, man. Yeah, look at that. Simple problems like this, simple problems. This would get chucked into the garbage and replaced by, you know, that's debatably a professional piece of equipment. Do you think someone, you know, that thing cost me cheap used, but, you know, those things retail. If you buy a new Atomos recorder now, you're spending at least $1,000 of Canadian money. That thing probably cost easily that much when it was new. Do you think a professional who spends that much money on a piece of equipment is going to bother repairing this? No. They're going to throw it out and get a new one. Why? Because damn it, little wire just came loose. This is one of the first examples, I think, fairly on my channel of why I get to have nice things. Because sometimes simple little stupid things break on them and that's all it takes to fix them. And that's what I do. I fix them. I thought I was going to have to hack this thing. I thought the power supply was going to be dead and I was going to have to go and figure out a new one. Repurposing this battery adapter and putting some other power supply on it. But no, the power supply is fine. And I'm guessing this thing's of decent quality. Like, it does say made in China, but it also says UL listed. Now, I don't know if you understand what that means, but in order to sell a piece of electrical equipment on the market and actually have stores be willing to take it and be waived of the liability if something goes drastically wrong with it, to put it on the manufacturers, it has to pass some sort of inspection. UL listing, Underwriter Laboratories is one of the big names in the game, and they will actually inspect and test on this thing to make sure that it's designed, that it's made up to reasonable quality standards, that it is safe to be marketed as a consumer device. That way, if something goes wrong with it, insurance companies can step in and say, yeah, well, it looks like this was a quality piece of equipment, and you know, flukes happen. Things go wrong sometimes. And then you're covered. Your business is covered. The store who sold it to you was covered. Now, there is another authority out there who investigates, and that's ETL, Edison Technical Laboratories, if I recall correctly. But to the best of my knowledge, their quality standards isn't that high. A lot of Chinese-made consumer goods that you find off the shelf, they're going to have the ETL listing. So that's kind of how you can tell the quality of a piece of electronics. If you look at the back, every single one is going to have that stamp of approval, and it's either going to be UL or ETL. The ETL is the cheap stuff. They tried to cut corners. The UL, that's going to be more quality, you know? Anything you install in your house as far as light switches and stuff has to be UL listed. Electrical components of that nature, and you know, often stuff that is in industry is UL listed. If you look at the Milwaukee tools, I've noticed they're all UL listed. So if it plugs into the wall, it has to pass standard. But things do happen. But at least this wasn't a safety concern. You're not really going to be able to see this solder joint that I'm making. And my fluxed out. Solder doesn't flow nice when the flux wears. Fluxed out again, because I can't hold it still because it's getting my fingers hot. I'm used to getting burned. And there we go. It's reconnected. Now that piece of heat shrink, let's just slide that back over there. I don't know why that heat shrink wasn't shrunk. I guess I'll take it upon myself to give it a little shrink. It's a bit oversized anyway. Now, how are we gonna get this thing back together now? That's the $1,000,000 question. Or, you know, the couple dollar question. Ugh, don't tell me I'm gonna have to use glue. Oh wait, just kind of snaps in there. Has to do with how recessed it needs to be, right? Yeah, I'll probably use some glue. I'll do that off camera. I'm not gonna bother gluing stuff right now. Oh, green tape. What I will have to do is a little bit of tape. Hopefully that doesn't interfere with the mounting solutions. This kind of tape goes wonky after a while, so it's not a permanent solution. Quite honestly, I hate gluing things. I wish I could bolt this. Maybe I can bolt it together. Just drill a hole through somewhere here that doesn't need to worry about mounting. That'd be hilarious. That'd be so like me to bolt this together. All right, so can we test on this before I go putting it all back together again? Yeah, I'm sure I can. All right, there's Mr. Atomos. Recorder, hi! Recording me right now. And if we go back to here, we could go to the battery display. And if we pop out battery number 2, it shows that the battery's been disconnected. Now, let's see if this thing will mount in there. It will. And now, if we plug it in, 9 volts AC. Yeah, that's a ticket. Right there. I don't want to have to run something like this off battery power if I don't have to. It's not that I don't like batteries, but when you're doing stuff like this, you burn through them rather rapidly, and cycling your batteries that much, you're gonna wear them down and have to replace them. It's one of the things that I dislike about this Nikon, because it only runs on batteries, and the batteries are about $100 a pop, and you get about an hour runtime off each. It costs $100 to buy an hour of runtime on this camera. Great. Okay, so let's see if we can get this business put back together. Another thing I'm probably gonna have to tape together. All right, let's get these improvised wires out of place here now. And we're gonna have to plug that back in. Now the ferrules. There's these nice ferrules. Are we able to get these back into place? Which way do we go here? They went in from this end. So I could probably just heat press those ferrules back into place. Like, yeah, that's one. And press the second one. That's two. We need to clear the holes in them. Small victory. That looks like a bit small though. Missed that one. Okay. I think I got those holes cleared out. Now on the back of this, I might want to reinforce some of the solder that is supporting those ferrules. Little operation you might not be able to see, but there's one, there's two. They're still seated nice. Now, you got to get these little springing clips back through these holes. Okay. Oh, I get one, but I miss the other. All right, there we go. See, I got to both back through the little holes. Now if we just solder them back into place. Oh, I forgot to put this little piece of plastic underneath the PCB. I might still have a little bit of flex though to work with. Yeah, there we go. Then that kind of jams into there. And now, where's the cover? Where's the other half? Where's my other half? Hey, right here. A little bit of tape on that too, it'll be fine. So now we clip this into place. Now we plug it in. Now we voltage test on it. There it is. And now we officially test on it. Mr. Atomos, come back over here. So, with the redundant power that the Atomos recorder has, I can, without disrupting it, pop out the main battery. And it'll just automatically transfer over to the second. And it's still recording. That's what's great about this thing. And then we take our AC, we'll put it in the main battery bay. There it is. Now, we should be able to remove the second battery and yeah. There we go, we're back on AC power again. Crisis averted. I didn't know what to expect when I found that thing wasn't working. Thought it was just a case of another blown power supply, but no. It was an even more simpler and dumber problem. A problem that probably would have created waste as previously discussed, but now I don't have to worry about it because I went on to the eBay where I usually can find stuff like this, and I checked to see how much a replacement one of these was gonna cost, and well, it was easily gonna be $100 bill. $100. And I would have needed one. That or I would have had to order more batteries to burn through. So, $30, $100, either way, money saved. Something, again, is repaired. And yeah. Welcome to the party.